Let's learn about the fundamentals of electronics. Our objectives are that at the end of this lecture, you will understand what are semiconductors. You will also know what are P and N type semiconductors. We will talk about PN junction diodes and their applications. Similarly, we will also talk about the fundamentals of transistors. I hope you will enjoy learning these concepts. Before I can talk about semiconductors, which are important components in electronics, first we can talk about conductors and insulators, because then it would be easy to talk about semiconductors. So you know what is this? It's a commonly used battery. It is marked with positive and negative terminals, and when you connect these terminals through wires and with a bulb, you see that bulb will light up. So you know what is happening when we connect two terminals through an electric bulb. What happens? Let's see it in more detail. So here I have a battery and then I have a bulb, and let's see what happens when I connect a wire, one end of the bulb with a wire and then other end of the wire with a one terminal of the battery. Similarly, I take another wire, I connect one end of the wire with the other terminal of the bulb, and similarly other end of the wire with the other terminal of the battery. As you can see, that bulb is lighten up. So you can see that something is happening. Some negative charges are moving through the bulb and then they are going to the other terminal of the battery, and these charges are marked as negative. So we will see what does it mean. So when these charges move through the filament of the bulb lights up. So we will see in more detail about these charges and the structure of the battery. Before that, I want you to observe one more thing. You see, this wire is connected to one terminal of the bulb and then other end of the wire is connected to one terminal of the battery. So now I am removing it. Now I will remove this wire as well. So you see the terminal of the bulb is connected with this terminal of the battery. So I am removing it as well. The next I will do, I will connect a wire with this terminal of the bulb, and you remember that when the last time I connected a wire with this terminal of the bulb, I connected other end of the wire with this terminal of the battery. But now I am doing opposite. I will connect this wire with other terminal of the battery. So it means I am reversing the terminals of the bulb which were connected with the battery. I just want to see if it makes any difference. So now I take another piece of wire, I connect it to the terminal of a bulb, and now this time that terminal is connected to the other terminal of the wire, and let's see what happens. Okay, so now once again I can see that negative charges are moving, and once again they are going to the same end of the battery, and bulb is also lighten up, and flow of charges is the same like before, and bulb lights up. It means changing the terminals of the battery with the terminals of two terminals of the bulb doesn't make any difference. This is an important consequence which I will remind you again after this after some moments in the lecture, because we will see a very interesting phenomenon later in the lecture. So just see that in both cases And these negative charges come out from this side of the battery, then they pass through the filament of the bulb, and then they go to the other end of the battery. And when I say that flow of charges is same, it means that they are still coming out of this end. They go through the bulb filament wires, and then they end up at the right side of the battery. So, but flow of charges inside the bulb filament is opposite uh, to the first case, because now terminals are changed. And I want you to observe one more thing. Suppose I cut off this wire. So I cut off one wire. So you see, now bulb is not lighting up. Why? Although one terminal is connected to the other terminal of the battery, but I have just removed one wire. And now the charges are not flowing through the wires and not through the filament of the bulb, and bulb is not lighting up. Similarly, if I delete, if I just remove this wire and I connect this end of the bulb to this end of the battery, still charges are not flowing through the wires and not through the filament of the bulb. So it means it only works when two terminals of the battery are connected to the two terminals of the bulb. Only then the charges will flow through the wires and bulb will light up. So we have seen that when we connect one terminal of the battery to the other terminal of the battery through a bulb, bulb lights up, negative charges or electrons come out of the negative terminal of the battery, they go through the filament of the bulb, and then they end up to the other or positive end of the battery. And as a result of this flow of negative charges, the bulb lights up. So I want to talk that what is the magic inside the battery which behaves like that, or this phenomenon occurs. So you can consider a battery like it consists of two separate chambers. So in one chamber they have collected or stuffed negative charges or electrons. So they have filled this chamber with a lot of negative charges for you. Similarly, they have filled other chamber of the battery with positive charges. And there are a lot of positive charges in this chamber. And also remember that there is no connection between these two terminals. So there is no way these two charges come across each other inside the battery. So they are isolated. These two chambers are totally separate from each other. Unlike the animation, because in the previous animation it was showing like charges are moving inside the battery. So they don't actually, they have no connection with each other, these two chambers. So now this chamber which is connected, the chamber which is full of negative charges, you are given a connection with a mark negative. Similarly, the chamber which is full of positive charges, you get a connection to this chamber and there is a sign of positive sign, because it shows that positive charges are accumulated in this chamber for which you are given the connection. So when you know that a positive charge and a negative charge has a fundamental attraction between each other, and that is Coulomb attraction, and you must be familiar with the Coulomb's law, that opposite charges attract each other and same charges repel each other. So you see that you have a lot of negative charges on the right chamber of the battery and a lot of positive charges on the left side chamber of the battery. So naturally they have a natural attraction between them and they want to come closer to each other. But as I told you that these two chambers are isolated or separate from each other, so they have no way to come closer to each other from inside the battery. When you make a connection from this chamber, suppose the negative terminal, which is the terminal to the chamber which is full of negative charges, and then when you connect these two terminals, the charges find a way to mix up with each other because of the attraction. So you see, when you disconnect, suppose I have a wire here which ends up here and I have a small opening between these two wires, still they will not flow through the wire, right? Because there is an opening and they can't travel through air. So still you will not see any flow of charges. So when you connect these two terminals of the wire or through a bulb, then they find a very nice way to come closer to each other. They mix up the electrons, they start flowing through the wire and through the terminal of the bulb, and they end up to the positive chamber where they just neutralize. And because the filament of the bulb it is also a wire but with very high resistance. Resistance is a property of a wire or material that it offers high resistance to the flow of electrons. So when electrons want to flow this filament, they face very high resistance. But still, because of the Coulomb attraction, they make it through the filament. But as a result, this resistance produce light. So you see that resistance in terms of heat or visible light, and that's why the bulb lights are up when we see the flow of charges through the filament. And now you can imagine that this flow of charges will slow down with time when this chamber, which is full of negative charges or electrons, empty with time. Of course, there is a limited collection of negative charges, and when they start flowing, the amount of negative charge will decrease in this chamber, flow will decrease, and a time will come when this chamber will become empty or almost empty, and flow of charges will stop and bulb will get dimmer and dimmer, and finally it will just stop lighting. So in this way a battery will become completely empty, there are no charges stored, and that is the end of the battery. Okay, now there are few questions which we should think about. If I ask you a question that suppose I have a setup like this, I have a battery, I have a bulb, and if I connect the bulb with the two terminals of the battery and bulb lights up. So my question is, how long the bulb will be lighting up? Because this is a very important question. So to answer this question, there are many parameters we should consider before answering a question like this. The first question is, how much or how many charges are accumulated at the chambers of the battery, negative and positive terminals or chambers. How many charges are stored? Because batteries come with different capacities. So this is another question. Then I have the question that what is the resistance in the wires, and also the resistance offered by the component if there is any component in my circuit. So the first parameter is very important. The first parameter says that we should know how many charges are stored. Of course, because if more charges are stored, it will take longer time to discharge this battery or neutralize this battery, because if we have more charges, it means we have a lot of charges and it will take a lot of time to consume all of those charges. Similarly, resistance, because if it will resist the flow of electrons or negative charges through the wires, and then the flow will decrease, and if flow will decrease, you see that it will take longer time to empty this chamber. So before that, I want you to consider a quantity. It is called potential difference, or in simple way we also called it voltage. You see, when you see a battery, it comes in different voltages, for example 1.5 volts. And if you want to do an experiment like this, you can buy a bulb, and then you can buy a few pieces of wires and then a battery. And if you want to perform this experiment, you should know that what voltage of the battery you require to light up a certain bulb. Then you should have information about the bulb, that what voltage a bulb needs to light up, and similarly you need to buy the relevant battery with the correct voltage 1.5. So it is the voltage or potential difference of the battery is an important quantity. So let's talk about this, and then we can go into the conductors and insulators. So before I can talk about the potential difference of a battery, let's see an analogy from a gravitational potential energy. So here we have a water tank at certain height from ground, and I want to fill water in this tank. So of course you know that you need a pump or some other machine which can suck water from earth, and then it will pump water to the water tank through a pipe. So it will take some time, and you can get a water tank full of water. So my question is, did you do any work in bringing the water from the ground up to that height h, suppose, to fill this water tank? Did you do any work, and what was that work? So you know that when you fill water, you have to do some work against the force of gravity, because you are bringing the water at certain height h. Suppose the height h is height of the surface of the water in the tank or whatever. And you know that when you fill water in this tank, this water has a potential energy mgh. So m is mass of the water in the tank, height is the total height of the water, and of course g is gravitational acceleration. So water has this energy because of this height h, because now you brought it at certain height h, and you worked against the force of gravity in bringing the water from the ground to up to this height, and that's why this water has a potential energy. So now here, suppose you have a pond and you want to fill water in this pond using this water tank. So what will you do? So before that, assume that you have put water in this water tank, and now this water has this energy mgh because it is at certain height. And because of this potential energy, the water wants to come down to the ground where you have taken it up to that height. But unfortunately, water has no way to go down to the ground. But if you give water a proper way to go back to the ground, it will happily go. You just have to give it a proper way. Unfortunately, in this condition, it is confined in this water tank and it has no way to go back to the ground. So now if you want to fill water in this pond, so you have to give this water a proper way. Suppose you will make an opening at near the bottom of the water tank through a pipe, and you will see that once you open this pipe, water will immediately start flowing through this pipe, and you will see that now the water is filling the pond. And my question is, will you do any work in bringing the water from this height to this ground level or in to fill this pond? No, you will not do any work. Water will do it to you. because you have already worked in bringing the water from ground level to certain height. Now that water has a potential energy and it will use that potential energy to go back to the ground level or near to ground level. So the only thing you have to do is to give water a proper way so that it can go back to the ground. Now if I ask you a question that how much time it will take to empty this water tank if you have an opening like this. So how much time it will take to empty the water tank? So your answer will be that it depends on two major parameters. The first is how large is the water tank, right? Because if you have a huge volume of water, it will take longer time to empty the water tank because you have too much water. And second question, if you think analytically and critically, you will say that it also depends on the size of this pipe through which you are emptying the water tank, or if you talk more precisely, radius or diameter of the pipe through which you are emptying the tank. If you attach a huge diameter pipe, of course it will take short time to empty the water tank because a large diameter of the pipe will offer very low resistance to the flow of water and it will empty very quickly. But if the pipe is very small, water will find it difficult to flow through it and it will take some time to empty the water tank. So the two parameters, size or amount of water, and then the channel through which you are emptying the water tank, because if channel offers low resistance to the flow, water will flow very quickly, and if you give resistance to the flow of water, water will find it difficult to flow and flow rate will be slow and it will take long time to empty the water tank. Okay, so now come to the battery. So you know that when I was trying to bring water from the ground to the water tank, I had to work, right? Because I was working against the force of gravity in bringing the water from the ground up to certain height h. So I worked against certain force and that's why that work was stored in the water in the form of potential energy. And when I wanted the water to bring back to the ground or near the ground level, I didn't need to do any work because water already had the energy stored in it. I just had to give it a proper way so that it can come back to the ground because otherwise it had no way to come back. Otherwise, although it wanted to go back, but it had no way. So now come to the battery. When we have a battery, I told you that the general structure of the battery is like that. It has two chambers. One is full of negative charges, other is full of positive charges. That's why it has two terminals marked as positive and negative, showing that the connection you have is connected to the chamber full of negative charges, and similarly the terminal you have as positive, it means that this connection goes back to the chamber which is full of positive charges. So now I want to charge this battery, or I want to fill charges into the chambers so that my battery is ready. So here suppose I have this collection of positive and negative charges and they are infinitely away from each other. Here it looks like they are very close to each other, but just imagine they are far away from each other. So now I want to charge the battery. Just consider the analogy I have presented before and now see. So my question is, I want to bring this negative charge into this chamber so that I can charge this side, or I can fill up this side with negative charges. So I have brought one negative or an electron or one negative charge from this place into this chamber. Did I do any work? And just give me the answer. Did I do any work in bringing the charge from just arbitrarily from out of the battery into this chamber. Did I do any work? And please don't say about gravitational field or gravitational force, because we are talking about elementary particles, electrons, just ions, and we ignore gravitational effects if there are any, because they are very less. They don't have almost, they are negligible. So don't say that I worked against the force of gravity or something like that, because that was only the case when we were filling the water tank at certain height. It has nothing to do in this case. And my question is, I brought a negative charge from infinity to into this chamber. Did I do any work? If I did any work, what was the field or force against which I did some work? Because usually we work against certain force to do some work, right? So did I do any work? Okay, now I bring the second charge here. So did I do any work? Let me tell you. When I bring the first charge from infinity into this chamber, I didn't do any work. Now I bring the second charge and I had to do some work. Although it's not that much, but I had to do a little work in bringing this charge from infinity to into this chamber where a negative charge was already there. Now when I bring the third charge, I had to work little more than the second charge in bringing this negative charge or electron into this chamber. And when I bring the fourth charge, I had to do even more work than the second and third charge in bringing this negative charge into this chamber. So now can you tell me that against which force or field I had to work? Because when we do work and that work is stored in the body in the form of a potential energy, we had to work against certain field or force. And can you tell me what is that force? Yes, that force is the force of the force is Coulomb repulsion, because you know I am bringing similar charges into this chamber, and when I bring the first negative charge, there is no charge in this chamber, it is empty, so I did not do any work because there was no field against me. When I bring the second negative charge, you see they are similar charges, and same charges always repel each other, so I have to do certain work to overcome the Coulomb force of repulsion, because one negative charge is already there in the chamber. Now when I bring the third negative charge, I had to work against the repulsion from two charges which are inside the chamber. And similarly, when I bring the fourth charge, I had to work against three negative charges. And in this way, the work will keep on increasing every time I bring another negative charge to fill this chamber. And same is the case for positive charges. When I had to work. Of course, I didn't need to do any work for the first charge because there is no charge inside the chamber. And when I bring the second, I had to work against it because they are same charges, and same charges repel each other, and I had to overcome that force, and to overcome that force I had to do some work. So you see, when I am charging the battery, I am working. I had to do some work, or I have to consume some energy to charge this battery, and once the battery is charged, I can get back that work or energy. The only thing I have to do is just to give them a proper way so that they can neutralize, because now I have positive charges here, negative charges here, and unfortunately they are confined, like the water was confined in the water tank, and I had to give it a proper way so that it can neutralize itself, or it can go to the equilibrium. Same is the case here. I worked against certain field, and that work is stored in the form of certain type of potential energy, and now I can get back that energy or work by joining these two terminals. And I can get back that work by joining these two terminals, and I have to give them a certain way so that they can come closer to each other or neutralize themselves. And that way is by joining this terminal through a wire, and I can put any component if I want, maybe a bulb, and then I will join other end to the positive terminal of the battery, and you know that electrons will just start flowing through the wire, and if there is any component, through that component, and then they will end up to the positive terminal of the battery, and of course they will neutralize. And you see that now if I ask you that how much time it will take, suppose I am lighting up a bulb, so how long can I light a bulb if I connect this bulb with this battery? So once again you will say it depends on two parameters. The one is what is the capacity of the battery. It means how much charge is stored on its terminals, of course, like how much volume of water was stored in the water tank. Similarly, it also depends on the medium through which they are going to the positive terminal. If there is a component, what is the resistance it is offering to the flow of electrons or negative charges, and this wire, if they have any resistance, because it depends. And these two major parameters will define how much time it will take to empty the battery. And now here is the concept of potential difference or the voltage. So basically the voltage is the pressure which causes the charges to flow into the circuit. In the similarly, the water pressure or pressure of the water is the driving force which causes the water to flow through the pipe. And you can also see the analogy that when the volume of water in the tank is decreasing, the flow rate will also decrease, and after some time when the tank is empty, it will stop flowing. In the same way, when the negative charges are flowing through the circuit, the amount of charge in this chamber will start decreasing, and as a result the flow of these electrons will decrease, and at certain point it will stop flowing. And one more analogy, when we are dealing with the liquids and they are flowing in the pipe, we have a quantity, it is called volume flow rate. To have a look at the flow rate, we have a quantity so that we can monitor how the water is flowing, and this is volume flow rate is volume per unit time. In a similar fashion, we have here a quantity, it is called current, and it is the flow of electrons or charge Q, whatever charge is involved, per unit time, and we call it current because as a result to know that the charges will flow in the circuit, and that flow is charge per unit time, and we call this quantity as current. So a voltage or a potential difference is the work done per unit charge to bring it from certain location to a point B, and it has a unit volts. We represent it as V, and this is the potential difference. So in a similar way, a potential energy or gravitational potential energy is with respect to is a reference point. For example, this mgh is actually I should call it h1, and I should call ground level as h2. So this potential energy mgh1 is with reference to h2 because it has certain height from certain point A and certain point B. So this potential energy is with reference to the point A on the ground. Similarly, the potential difference is also between 2 points. So when we measure the potential difference of a battery, we measure between the negative and positive terminals. So usually we represent positive terminals with a long bar and negative with a short bar, and we can measure the potential difference between these two charges. Always remember that potential energy, even whether it is gravitational or electrostatic, it is with respect to a certain reference point. Okay, so I want to explain one more thing, that the potential energy, whether it is gravitational potential energy or electrostatic potential energy, it is always with reference to certain point. For example, the volume of water has a potential energy m, g and h1 because the height of the water tank from the ground level is h1, so it is mgh1. But this potential energy is mgh1 to what reference? So I took reference as ground. So from the reference point of ground, the potential energy of this water is mgh1. But what if someone is standing here and he wants to know what is the potential energy with reference to his position? And let's suppose the height of this person from the ground is h2. So h2 is the height from ground to the lower ground. So now can you tell me what is the potential energy of this volume of water with reference to this man? Yeah, let's call it C, or with reference to a point C here. So that potential energy will be, the volume with reference to point C will be mg h1 plus h2. So you see the water is at the same place, but just because the position of the reference point has changed, so its potential energy is now different because the volume of water is higher for this person at point C here at the lower ground. So the potential energy is greater for a person at C than for a person at G, because now the height h2 is added and it is higher. And that for a building, suppose there is a multi-story building and there are 3 floors and there is a water tank at the roof. So for the same water tank, if there is a washroom at the 3rd floor, they will feel less pressure of the water when the water comes out of the shower or the faucet. They will feel like pressure of the water is not that much like the pressure for the person at the 2nd floor. So they will feel like now pressure of the water is greater for them. You see, water tank is at the same place, but just because persons are at different levels and they are at different heights, they will feel different pressure of the water, or in other times they will feel different potential energy just because the position of that person who is observing is different. So the person at the ground floor will see that the pressure of the water is too much with reference to the 3rd or 2nd floor. So this is why the potential energy is always up to a certain point. So when I ask you what is the potential energy of a water tank at a building with a height h from the ground, so you may ask that potential energy with reference to what? Whether my reference is ground, I want to know what is the potential energy with respect to ground so that you can take the whole height h, or potential energy with respect to the 2nd floor Then of course you have to subtract this height, certain height h2, and then you can calculate, because then it will show less potential energy. And of course same is the case for the third. So a potential energy, gravitational potential energy, is always with reference to certain point, and you calculate it between two points. Now let's come to the electrostatic potential energy. You know that we have filled up these two chambers with positive and negative charges, and we have done work on each charge in bringing it into this chamber. So now what is the potential difference across the positive and negative terminal of this battery? So let's suppose this terminal is at negative 4 volts and this one is at plus 4 volts. So the potential difference would be between these two terminals. We always represent positive side as a longer bar, longer vertical bar, negative with a short vertical bar, and potential difference is 8 volts, because plus 4 and this is potential difference, so minus negative 4 volts equal to 8 volts. You see the potential difference is 8 volts. Similarly, sometimes we can have a situation where the power supply or the power source or the battery, one end is at negative 4 volts, but the other end is at neutral or ground level. It means it is at 0 volts. So now what would be the potential difference across this battery? This one is still as positive with reference to the negative charges, and here is the negative terminal, and this one is at 4 volts. So if you connect a component across this battery, it will feel a 4 volts across its terminals in ideal case. Similarly, when you have positive and negative, then potential difference is 8 volts. So I want you to consider a situation like this, that how the potential energy or potential difference in specifically in this case is different just because there are different points at different potentials. For example, now let's see that this one is at plus 4 volts. This is neutral, or sometimes we call it ground, or it is at 0 volts, and this one is at negative 4 volts potential. So when you want to connect a component, you have to see that will be the potential difference through which you are connecting the terminals. As you can see that plus 4 is at higher potential than ground, and then negative 4 volts is at lower potential than both of these levels. So for example, you want to connect a bulb between terminal ground and negative 4. So what is the potential difference across the bulb, and what do you think if the bulb will light up or not? Just assume that the voltage rating is in the same range of the bulb. Yes, so the voltage across the bulb is positive 4 volts across this bulb, and of course the current will flow from, because electrons will move to the higher potential level at the which is at the ground or neutral, and in this way of course the bulb will light up according to the scheme, because I usually take lower potential at the end and higher potential at first, the way I take the potential difference. But this whole scheme is arbitrary and it's up to you. You may choose a different scheme, it doesn't matter, because potential difference is always the same and sign will just show you the direction of flow of the current or something like that. Similarly, if I connect the same bulb with these two terminals, what do you think is the potential difference across this bulb, and will this bulb will light up or not? So once again, the potential difference, I always take the higher potential first. So it's once again plus 4 minus 0 volts, and hence the total potential difference across the bulb is plus 4 volts. And of course the bulb will light up, and the direction of the current is from the ground terminal to the positive 4 volts, because here we have a deficiency of electrons also. So if there are some electrons, they will just travel to plus 4 direction to neutralize as much as possible. And now if I put the bulb across these two terminals, negative 4 and positive 4, so you know what is the voltage. So plus 4 volts minus into negative 4 volts, it's 8 volts. So now you will see that bulb will light up brighter than the first two cases, because it is experiencing higher voltage than the other two cases, in fact double voltage in contrast to the first two cases, and the voltage is 8 volts. So potential difference is always with reference to some other point, and then it matters with what is the level of those 2 points. This is how we always take the potential difference, and you will face it in your experiments in the laboratory when you will apply voltages across different terminals. So just a concluding remark, let me tell you that why this current flows like this. Even in this case, the last one, the current will flow from negative electrons will go to fill the holes here at the positive terminal, because there is deficiency of electrons. So I tell you that everything ends up at equilibrium. Suppose you have a tank and it has two sections, and you fill water here in one section, and then there is a barrier. So everything wants to end up at equilibrium. So suppose if you have water here, so this water is confined in this space, so that's why it is there. But if you remove this barrier, what will happen? Water will flow into this area, and then it will end up at equilibrium, a same height, and of course then it will stop because it is confined with those walls. You see, you collected some mass of water in this section, but there was a barrier, and when you remove the barrier, there is an empty space here. There is no water. So water will try to end up at equilibrium. It will try to neutralize, or it will try to be at the minimum potential energy available to it. So when you remove the barrier, it will find a way to minimize its potential energy. It will spread out across the water tank and to minimize the potential energy. Same is the case here. When you have charges at different levels, for suppose negative charges, here you have a collection of negative charges, and then you have a point where there are no charges or neutral charges. Then you have a place where you have plus 4 or a deficiency of electrons, or in other words I can say positive charges. So they are at different levels, and whenever they come in contact with each other, they try to neutralize or to maintain a minimum electrostatic potential energy. That's why current flows from one level to the other level according to the scheme or the distribution of charges. Okay, so now we can come to the point. So when I was talking about this water tank and I told you that if you want to bring this water to the ground, you have to give it a proper channel so that it can come back to the ground. And that channel was a hollow pipe so that it can travel inside the pipe and it can come down to the ground, and you don't have to do any work in bringing the water from this height to the ground. You just have to provide a proper channel so that it can come back to ground. And that channel was a hollow pipe so that it can travel through. What if I give you a pipe which is not hollow, it is filled from the inside, it is solid? So what do you think, if water will come down to ground or not? No, because that is not a proper channel. Water needs some hollow pipe so that it can travel because it is liquid and the mass will flow through the pipe. And if you don't give a hollow pipe, then of course it won't find any way to go through it, right? Similarly, did you see that when we connect wires or we want to connect a bulb between two terminals, we always use wires. You will never use a plastic or any other material. There are some specific wires or any materials which you always use in the circuits when you connect positive, negative or ground terminals, and then the bulb will light up. So my question is, what is so special in the wires we use in our daily life or certain material that only they can be used to transfer the charge across two terminals, for example, negative and ground? So what is so special in those materials or in those wires that only they can be used for that? And of course, there are some good and bad materials. Some materials are very good for the transmission of this electronic charge, and others are bad. Some are very good, and some are worst. You will never want to use them. So we need to have a look into the material or characteristic of those wires and materials so that we can see why they are good conductors of electricity. The flow of charge, we call it electricity. And of course, like I said, we need to give a proper channel. So next we will look into the material or of these wires and mediums.